Morning, guys. I'm Raul Miraj, and I will be talking about factorization. So you're watching my algebra lecture series, where I'll be discussing the common factor and the difference of two squares. So let's get started. So the common factor is a factor that divides each term. For example, 2x plus 4 is 2 into x plus 2. Notice 2x divided by 2 gives us x, and 4 divided by 2 gives us 2. Okay? Let's do another example. 2y squared plus 4y to the power 4. We can take 2y squared out as a common factor, and that will give us 2y squared into 1 plus 2y squared, because 2y squared divided by 2y gives us a 1, and 4y to the power 4 divided by 2y to the power 2 gives us a 2y squared, if you recall your laws of exponents. Let us factorize the expression x to the power 5 minus 4x cubed. Pause the video and work it out. We can take x cubed out as a common factor. So x cubed into x squared minus 4, because x to the power 5 divided by x to the power 3 gives us an x squared from the laws of exponents, and minus 4x cubed divided by x cubed gives us minus 4. You guys may think this is the final answer, but no, it's not, because in brackets we have a difference of two squares. So the final answer is x cubed into x plus 2 times x minus 2. And that brings us to the difference of two squares, which takes the form x squared minus a squared. And the factorized version is x plus a into x minus a. Let's look at some examples. Let's factorize the expression y squared minus 64. 64 is 8 squared, and y squared is y times y. So therefore, these are just two perfect squares. And the factorized form is y plus 8 into y minus 8. So here's a table of squares. If x is 0, then 0 squared is 0. If x is 1, 1 squared is 1. If x is 2, 2 squared is 4. If x is 3, 3 squared is 9. If x is 4, 4 squared is 16. And if x is 5, then 5 squared is 25. And you can go on and on. I dare you to construct a square table where you have x being 0 all the way up to 1,000 or 1,000,000 or a gazillion, based on how much time you have. Try doing that during your December holidays. Factorize the following expressions. A, we have p squared minus 16. B, we have 4q squared minus 64. And we have C, which is 2z to the power 4 minus 128 z squared. I encourage you to pause the video and work it out. So in A, we have p squared minus 16, which are two perfect squares, because 16 is 4 squared. So the factorized form is p plus 4 into p minus 4. In B, we have 4q squared minus 64. We need to get q on its own. And to do that, we take 4 out as a common factor, which gives us 4 times q squared minus 16. And we already factorized what's in the brackets in A. So therefore, we have 4q plus 4 times q minus 4. In C, we have 2z to the power 4 minus 128 z squared. We can factor out a 2z squared, and if we do that, we'll have 2z to the power 4 divided by 2z squared is just z squared, and 128z squared divided by 2z squared is 64. And we see in the green brackets we have a difference of two perfect squares, which can be factored as a difference of two squares, as you can see over here. And this brings us to the end of our presentation. Well, no, not the end of our presentation. Sorry, my bad. Let's factorize the following expressions. S squared minus 8s minus 65 and B q squared minus 4q minus 5. So in A, we have s squared minus 8s minus 65, which can be rewritten as s squared minus 8s plus 16 minus 81, because 16 minus 81 is minus 65. We can enclose the s squared minus 8s plus 16 in brackets, and we know that s squared minus 8s plus 16 from our squaring of binomials is just s minus 4 all squared minus 81. Now this is a difference of two squares because 81 is 9 squared, and so we can factor it out as follows: s minus 4 plus 9 into s minus 4 minus 9, and if we simplify, we will have s plus 5 times s minus 13. In B, we have q squared minus 4q minus 5, which we can factor out the same way. So doing that, we can write it as q squared minus 5q minus 5, which can be written as plus 4 minus 9, because if you add those two numbers, they will give you a minus 5. And q squared minus 4q plus q, from our knowledge of squaring binomials, we know can be written as q minus 2 all squared minus 9. And we have a difference of two perfect squares, which we can factorize as a difference of two squares. And then we simplify and we get the factors q plus 1 times q minus 5. So now this brings us to the end of our presentation. I apologize for what happened earlier. And if you need to contact me, you can email me on rawalmaraj523@gmail.com or WhatsApp me on +27 73 483 5887 if you require a one-to-one consultation. God bless y'all and goodbye.